The Spiker Box is an original Backyard Brains invention. Quoting their website, Backyard Brains Spiker Box is a fun, affordable, hands-on way to experiment with neuroscience. The Spiker Box is used to measure and see the nerve impulses and action potentials of an organism attached to it. This would include invertebrates, such as crickets and cockroaches, which we tested.
Action potentials are when a neuron or nervous system cell reaches threshold and its polarity becomes more positive.
An action potential is made possible when neurotransmitter stimulates the chemically gated channels in the dendrites, allowing an influx of sodium ions. The action potential then starts when enough sodium ions flow into the neuron, making it positive enough to allow the voltage-gated channels to open. They are along the axon and the nodes of Ranvier. They allow more sodium to enter, which allows more channels to open until the action potential reaches the axon terminals, stimulating the release of that neuron's neurotransmitter. The Spiker Box measures the rate at which all of this happens. Soldering is the main way we attach things onto the Spiker Box. As shown in the video, you touch the soldering iron to the solder coil and allow it to drip on the metal, connecting the two pieces.
There are three main steps in assembling a Spiker Box. First is putting together a PCB board. Second, preparing the speaker and electrode. And finally, assembling those two parts in the final assembly.
The first step in assembling the PCB board is to solder in the top four connectors. They are the RCA plug, the light, the switch, and the audio jack. Next, you solder in the resistors, which can be identified by their color bands corresponding to numbers. After that, you install the capacitors, which are identified by the numbers on their yellow and blue caps. The 220 UF capacitor is the only one with polarity in it, and therefore it must have the white strip facing the top of the board. Then you will install the chips and chip holders, with the dot and the chips facing the top left of the board. Finally, you put on the battery by attaching it to the brackets and soldering them in. Do not forget to attach the speaker plug to the top right of the board. To prepare the speaker, all you have to do is strip the ends of the wire and solder them to the speaker connector, which eventually plugs into the connector on the PCB board. To install the RCA plug, you must strip both sides of the wire and attach one of the sides to the pins that will go into your organism, and the other side will be soldered to the inside of the RCA plug. You will do this by removing the yellow or green cap and then putting it back on.
In the final assembly, you will take the screws and layer parts on them in the following order: the bottom of the Spiker Box, the PCB board, the clear screw casings, and finally the top of the Spiker Box. The speaker will plug into the PCB board and fit into a hole at the top of the box. The RCA plug will go into the jack, and the pins will go into the pieces of cork that you stick on to the top of the box. This is our experiment, starting with procedures. Anesthetize a cockroach in ice water. Cut off the two legs and hook up each leg into your Spiker Box. Liberally coat one leg with petroleum jelly using a toothpick and start a stopwatch. Every minute, manipulate both the control and experimental leg by touching one of the barbs to see if you can invoke a spike. After a time, the experimental leg should stop spiking. Mark down the time when the spike stopped. Carefully remove the petroleum jelly with a napkin or paper towel. Restart your stopwatch. Every minute, attempt to evoke spikes. Eventually, they should return. Mark the time at which it does. Also, check if the control is still generating spikes. Repeat steps 2 to 5 as long as you have time and as long as the control leg is still generating spikes. Repeat this experiment over a couple legs to see if you can find an average time for the spikes to go away.
These are what you'll need to do the experiment. Our experiment looks at the effect of lack of oxygen to the nervous system cells of the cockroach legs. The first step is to pick out a cockroach from the container. After picking out the cockroach, you must put him on ice to anesthetize him and make him numb, so that way when you remove his leg, it will be as humane as possible.
As you can see, they're using tweezers and scissors to remove the leg of the cockroach. You want to make sure that when you are cutting the leg off, you want to be as close to the cockroach's body as possible. The removal of one of these legs will not hurt the cockroach, and he will still be able to live. After you cut off the leg, you want to take a little bit of petroleum jelly and put it on where the incision was.
After removing the leg, you will plug it into the pins on the Spiker Box.
You will then start recording the action potentials and record to hear if they are present every minute. You will do this for 50 minutes. The next thing that you will do is to take the second cockroach leg and cover it in petroleum jelly so that oxygen cannot diffuse into its cells. Then you will test the action potentials on the spiker box of it, checking it every minute for 50 minutes as well. Based on our research, the spikes should go out around 40 to 45 minutes. If you have two spiker boxes, you can do this at the same time you are doing the control, but otherwise you might have to break it up. Based on our research, the results we should have received should have somewhat gone as follows. The experimental leg should have stopped seeing nerve impulses about 40 minutes after cutting off the oxygen. The control leg should have never stopped having action potentials.
This sequence of yeses continues for all 70 minutes.
Our results were not as expected, as the leg covered in petroleum jelly never stopped having nerve impulses. We believe this was due to faulty wiring in the PCB board. The reason Dr. Monahan was given the grant for this project is because it was related to STEM education. STEM stands for science, technology, engineering, and math. The science part was incorporated in the actual study of the neurons of the cockroach. The technology were the spiker boxes, the engineering was building the spiker boxes, and the math had to do with calculating the data at the end of the experiment.